And welcome back. We are now going to look at how to define a proper equals method. Remember from last time we said with our toString, there wasn't much nuance that we had to really kind of deal with when we are pulling things from the object class. However, if we look at our equals method, it wasn't quite correct. And so we're actually going to take time to actually look at how we can construct that properly. So when we start talking about redefining equals, we had said, of course, that the class object, as I mentioned, has an equals method. And then when we define a class with the equals method, we could technically override that definition from our class object. And if we look at the heading for the method equals that we currently have in our class employee, we have public boolean equals employee, other employee. However, the heading for the method equals in class object is as follows: public boolean equals object, other object. And these might seem very similar. However, you notice one is a base type, employee, and the other one is an object type. So how do we go about redefining this properly so that we can actually override to the correct version that we are expecting? Well, the two equals methods have different parameter types, as we mentioned. One's an employee, one's an object. So we haven't really overridden the method of equals so much as we have overloaded the method equals. The class employee, therefore, has technically both methods named equals. In most situations, this won't matter because it's just going to use the one that you are specifying. Which one do you want to use? However, there are times when you do want to have that specificity in place. Some library methods, for example, assume that your class's definition of equals has the following heading, same as in the class object: public boolean equals object, other object. So let's get into how to properly define equals. We first need to look at how to change the type of the parameter for the equals method in the class employee from the type employee to the type object. Well, our first try might have something very similar: public boolean equals other object, employee other equals other employee object, return name dot equals other employee, and hire date dot equals other employee dot hire date. This is a good first attempt here. So we're just saying, hey, let's change that base type a little bit. We'll create like a employee object inside of this, and we're gonna go from there. Well, we need to typecast the parameter other object from type object to type employee, because you'll notice in here we have a typecast right here of employee. This is, of course, forcing this to be from an object type to an employee type. Now, if we take out that typecast, if we don't have this in here, this parentheses right here, and simply proceed with other object being the way it is, the compiler is actually going to give us an error message when it sees other object.name, because it doesn't know what that is. The class object does not have an instance variable called name. So let's work on improving our attempt to make it just a little bit better. The first try at an improved equals method does not override the definition of equals given the class object, and will work well in many cases. So because it does work. So we do override it. It works. It has functionality, but it still has a little bit of a shortcoming. Our definition of equals now allows an argument that can be of any kind of object whatsoever, which is not necessarily what we want. What happens if the method equals is used with an argument that's not an employee? What if we pass in, let's say, a string type? Or we pass in, let's say, a date type? All right, what we're going to be getting is a runtime error that happens when you try to typecast to employee, and it looks and says, this is not an employee type, this is, let's say, a string type. Those aren't compatible. What do you want me to do with this? It's going to compile out, and the runtime will just stop your program. So let's work on addressing that fault, that little bit of a shortcoming that we just looked at. We need to make our definition work for any kind of object. So if the object is not an employee, we simply need to say, hey, this is false, move on with life. If it is an employee, and if the argument is not an employee, they should not be considered equal. But how can we tell whether or not that parameter is of type employee? How do we know that it's actually an employee type? Well, every object inherits the method getClass as part of the class object, and that getClass is going to kind of be our little bit of a friend here as we start comparing those base types. The method getClass is technically marked as final from the class object, and because it's marked as final, it cannot be overridden, which is a real good thing, because if we could override it, we would have a big headache on our hand. So let's just say we have any kind of object of type O, and I say O.getClass. This is going to simply just return a representation of the class used to create O. For example, after the following code is executed, we say O equals new employee. O.getClass would then return a representation of employee because it is an employee type object. Now, this, of course, is going to kind of lead us into where we want to go with this, but we're not going to necessarily describe the full details of this representation, except pretty much we effectively want to know that two such representations should be compared either with equals equals or with not equals if we want to know if those representations are the same. Thus, the following code is going to output same class. So if we look, we say if object1.getClass is equal to object2.getClass, we can say, hey, this is the same class. Otherwise, we'll say it's not the same class. So if object1 and object2 were created using the same class when they were created using new, because it's the new keyword there, well, the code would then output not the same class. So let's bring this all together now. And I know it's kind of been a lot of high-level stuff, but how do we look this to actually create an updated version of equals, the way we want this to actually be represented within our code? Well, our final version of the method is as follows. We have public boolean equals other object, and we have our if other object is equal to null, return false. And it's very important that we have that in there first, because first we have to make sure that the object exists. Otherwise, well, if you don't have an object compared to, well, that's going to be a problem. Then we, of course, say else if getClass does not equal other object.getClass. We're going to return false as well there. So that's looking to see, again, we're testing for equality. And then we have our else statement. And then this is going to kind of be the thing that we would normally have within a program. Else employee, other employee equals employee, other object. And notice there's our typecast. Can't forget that. Return name.equals other employee.name. And hire date.equals other employee hire date. So note that with our new definition, we have also taken care of one or more possible cases here. As I already mentioned, we have other object equals null, so that's a good way to test to see if an object actually kind of exists of that other object. Now, the predefined constant null can technically be plugged in as a parameter of type object. The Java documentation actually says that an equals method should return false when comparing an object and the value null. So that's actually something we want to leave in there because, again, if an object is set to null, that's technically a valid value, but it's not necessarily going to return values that we expect. So we just want to make sure that we have that accounted for. Now, if we look at here in our employee class, I went ahead and added the other equals method here. And of course, you're welcome to add that into your program, but you'll see now we have our normal kind of equals method that we expect, employee, other employee. And then of course we have our normal parameters. And then we have our proper equals method that we are now using. And this is what we're going to kind of want to use going forward. So you notice that this right here, this return statement that we had from before is now nesting right here inside of my else statement. So effectively, we're always going to have these sets here. So this if, this else if are always going to be here as part of our program. And then we're going to have this else here that's going to end up taking place of this here. So this is what we should expect to see for our equals methods going forward. And if you have this, again, this is not necessarily bad and will work in most scenarios. However, it's not necessarily the best approach. This is, of course, a much more aligned approach to make sure that we are getting a proper test and representation, because we are not overloading our method then. We are now overriding it from the object class.